Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem two repeated elements. This problem has been asked in some companies as well. So let us quickly read the problem statement and see what the problem says here. The problem says that we'll be given an array which will be consisting of n plus 2 elements, and all the elements of the array are going to be in the range 1 to n. Okay. Also, all elements occur once except two elements. So two elements are going to be there that are occurring twice, and rest of the element are occurring one time only. So that is why the total number of element is how much? Total number of element is n plus 2, because rest of the element are occurring one time only, but two elements are there that are repeating. So total number of elements will be n plus 2 in the array. Now after this, you have to find the two repeated elements in the order of their occurrence from left to right. For example, if we will see this particular test case, that is we have got 1 2 1, then 3 4 3. So in this particular case, you can see that we have the element 1 that is repeating, and then element 3 that is repeating. So we'll return 1 comma 3 because 1 is the first element that you see that is repeating, and then after that 3 is repeating. So how can we solve this particular problem? In order to solve this problem, the very basic approach can be that we can take help of map data structure, and we can iterate through every element, and if it is coming for the first time, so then we can say that we'll increase its frequency. Otherwise, whenever we are at an element and its frequency is already 1 inside the map, so we can say that that particular element is repeating and we can store it inside our answer. But if we will do this particular approach, then the time complexity will be order of n, but the space complexity will also be order of n, because in the worst case, we'll be storing all the elements of the array inside the map. If we have to solve this in a better and optimal manner, so we need to reduce the space complexity to constant. Now, how can we reduce the space complexity of this particular question to constant approach? So what we can do is, whenever we will be at a particular element, let's say ARR of I, so what we will do is we will mark, like suppose that we are at ARR of I, and suppose that ARR of I value is let's say 5. Assume that ARR of I value is 5. Then what you will do is you will mark the element at the index 5 as negative. Okay, and later on, when again your ARR of I will be 5, and then when you will go to that element to mark it as negative, it will be already negative. So then you will say that element 5 is actually the repeating element. Let's see this by doing the dry run on the test case. So what we will do here is, let's say we will initially start from the very first element, that is 1. So when we are at the element 1, so we will go to the index 1 and we'll mark it as negative. So right now the element at the index 1 is not negative. So let me mark it as negative. So now instead of 2, it will become minus 2. Then after this, what will happen is, next time we will go to the second element of the array, and whatever element is present here, it is minus 2 that is present. But actually, since we are talking about indexing, so we'll take absolute value here, and the absolute value will be 2. So at index 2, now I'll mark the value as negative. So now this will be minus 1. After this, we'll iterate further, and then we will be at this particular element. Now, when we are at this particular element, that is the element third element of the array, which is present at this particular index. So now we will take the absolute value. What is the absolute value of this element? It is 1. So now absolute value of this particular ARR of I is what? When I is standing here, is nothing but 1. So now I will say that at this index, I will mark the element as negative. So when I will go to this particular index, so you can see that this is the index 1. So when I'll go to this index, you can see that already the element is negative. So this means that I have already made the element at this particular index as negative. So this means I have already hit this index already, because 1 was already present here. So I have already hit this particular element and I have marked it as negative. So that is why what I will say here is that in my answer, I will store this particular element, that is 1, because it must be repeating. Because if this index is being hit 2 times, the second time, how can I check if this index is being hit the second time? Because the element present at the index 1 is already negative. So this means that I must have made it negative before. And now since it is already negative, so it indicates that the second time I'm coming to this particular index, and I should store this because it will be a repeating number. Then after this, we'll move further inside this array. And now what will happen? We'll go to this particular element. Now when we are at this particular element 3, so 0, 1, 2, 3. So we'll mark this particular element as negative. Then we will move to the next element. So this will be 4. And we will say 0, 1, 2, 3, 4. So we'll mark the element at the index 4 as negative. So this will be itself marked as negative. Then after this we'll move to this particular element, and the element here is 3. So what we will do here is we'll say that we'll again go to the index 3 and we'll mark it as negative. So when I go to the index 3 here, what will happen? When I go to this particular index 0, 1, 2, 3, so it is already marked as negative. So it indicates that I am hitting this particular index for the second time. So then I will store the element 3 here, because I can say that this is repeating. So I hope you have understood this particular part. Basically the thing is, what we have done is, like whenever we are at a particular element AR of I, so we are iterating in this array and we are making the element at the index AR of I as negative. Okay, and whenever we are going to the element at the index AR of I, if it is already negative, so this means that I have already hit this particular index, which means that AR of I is a repeating element. So this is how we are doing it without using any extra space, and in constant space. By applying the operation on the same array, our job will get done. And always notice that whenever we are going to treat AR of I as an index, and we are going to update the element present at the index AR of I as negative, so we will always take the absolute value, because it might have happened that while doing the operations, like the element inside the array might have become negative. So that's why we'll always take absolute, so that we can talk about the index in terms of positive values, right? So let's try and quickly code this solution up and see how we can implement this. So what we will be doing here is we will simply start iterating inside this array. So first of all, we will be requiring let's say an answer array, vector int answer. Now after this, what we will do here is we'll iterate int I starts from 0, then I is lesser than n, then we will do I plus plus, and after this what we are going to do is we are going to first of all check that if what happens is, if the element that we are at, let's talk about this index. So let's say int, let's say the index will be what? It will be nothing but absolute of AR of I, because we are going to treat AR of I as the index, which we are going to mark as negative. So we'll check that if the AR of AR at this particular index, if it is what? If it is nothing but positive. Suppose if it is positive, so this basically means that I'm coming to this particular element for the first time, so I'll multiply it with -1. So into is equal to -1. So I'll multiply this particular element with -1. Otherwise, if it is already -1, the element at this particular index, the index is basically absolute value of AR of I. If it is already -1, so this means that this particular index has been already reached. So that is why what I will do is, inside my answer, I will basically push back this particular element that is absolute of AR of I, because it will be a repeating element. That is why I'm coming for the second time, and I'm seeing that the element at this index AR of I is negative. So we should store it in our answer. And at the end of the day, we will do what? We'll simply return our answer array, which will be consisting of the two repeating elements. Let's now try and compile this code to check if our code is working fine or not. So basically you can see here that we are not able to get something properly. I guess there is some issue with my yeah. So the thing is that array size is n plus 2, so I should run my loop from I starts from 0, I is less than n plus 2. Now it will work fine. Let's now try and submit this code, and it should get accepted, because we need to run for all the elements of the array. So yes, you can clearly see that our code was able to pass all the test cases. This problem is very good when you have to solve this in constant space. So talking about time and space again, so time complexity for my approach will be nothing but order of n, because I am taking iteration throughout the array. Then space complexity will be order of 1, because we are not taking any extra space. I hope that you have understood this problem. In case if you did, make sure to comment understood or +1 in the chat. And thank you for watching this video.